Hi there and welcome to this, the first video that I'll be doing on the exam questions for the A-Level S1 module for the edXL. It is applicable to most other exam boards, and if you're looking for further help with your studies, do check out youtube.com/Mr. Arnold's Maths. Okay, so this first video is going to be quite a long one. There's a whole ton of questions I'm going to do that are based on processing and representing data. And if you can manage to get through all of these questions, you have an excellent chance of getting full marks in the exam in this particular topic. So let's start the ball rolling. Our first question is from January 2010. It says, if 19 employees of a company take an aptitude test, the scores out of 40 are illustrated in the stem and leaf diagram below. And we're asked to find the median score. So if I go to my stem and leaf diagram and I see that the total number of leaves is 19, because it tells me there's 19 employees in the company. I'm looking for the median score, or Q2. I want Q2, which is going to be the 10th person. I'm just thinking about it in context. If I choose the 10th, that means there's 9 people that way, and there will be 9 scores before it. So the 10th value is the one we want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 33 is our median score. The interquartile range, well, I'm going to need to get Q1, and Q1 is n over 4. So we do 19 over 4, and 19 over 4 gives me 4.75, which means I'm going to choose the fifth number, the fifth value. So, counting along, 1, 2, 3, 4, 5. So the fifth value is 24. That's my lower quartile. And the upper quartile is going to be 3 times 19 over 4, which gives me 14.25. So I'm going to choose the 15th value. And the 15th value, counting along, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the 15th value is 40. So the interquartile range is Q3 minus Q1, which is 40 minus 24, which is 16. Okay, it says the company director decides that any employees whose scores are so low that they are outliers will undergo training. It says an outlier is an observation whose value is less than the lower quartile minus 1 times the interquartile range. Explain why there is only one employee who will undergo retraining. So we just got to do this test for outliers. So I'm going to take the lower quartile, which is 24, and I'm going to subtract 1.0 times by the interquartile range, which is 16. And 24 take away 16 is 8. And that means if we look at our stem and leaf diagram, there's only one person with a score less than 8. So only one person with a score less than 8. Okay, next part D. On the graph paper, we're asked to draw a box plot to illustrate the employee scores. With a box plot, I tend to start by always putting in the upper quartile and lower quartile. The upper quartile was 40. The lower quartile is 24. So starting with that, just to make sure. And the median was 33. So 30, 31, 32, 33. Now that's not close enough for my liking. With your box plots in the exam, make them as accurate as possible. I also know that there is an outlier that was 7. This was an outlier, and we always mark our outliers with a cross. So 5, 6, 7. So a red cross here to indicate my outlier. And then I have to put in the leaves. Now the lowest value, that is not an outlier, or the outlier test was at 8. So I need to put in a leaf here. And you'll also note that the highest value was 40. I've only got one of the whiskers in here. So I'm going to put in another whisker going in that direction, which is going to be the lowest value here. That's not an outlier, which is 18. So I'm going to put another whisker coming out in this direction, which is going to be 18. So just moving things so that they fit nicely. And my box and whisker plot is completed. Okay, next question. The birth weights in kilograms of 1,500 babies are summarized below. And part A, we're asked to write down the missing midpoints in the table. Now, here, the missing midpoint we have to put in, just in case you're unsure about how to find exact midpoints, because some of my students have made mistakes with this before, and I'm sure you guys are no different. So the easiest way to be sure is to add the lower and upper bounds together, and then divide your answer by 2. So add the bounds together, divide your answer by 2, 2.75. So it's 2.75 will go in there. And obviously the halfway point between 5 and 6 is going to be 5.5. Okay, calculate an estimate of the mean birth weight. Okay, now it's important that you realize that in the exam you have been given some summary statistics. So I've been given the sum of fx and I've been given the sum of fx squared. The mean x bar comes from the formula. When it's grouped data, the sum of fx divided by the sum of f. Now in this case, sum of fx we know to be 4,841, and the sum of f, the sum of the frequencies, has also been given to us here. It's 1500. If you didn't believe me, you could just add up all these frequencies here, but by interpreting the question, I can save myself a little bit of time. So 4,841 divided by 1500 gives me 3.2273. So I'm going to round that to 3 significant figures, so 3.23. And an estimate for the standard deviation of the birth weight. Standard deviation. Well, let's write down what the variance is first. The variance comes from the mean of the squares. So sum of fx squared over sum of f minus the square of the mean. Sum of fx over sum of f all squared. You have to know this formula here. And variance is known as sigma squared. So sigma squared is the mean of the squares minus the square of the mean. I'm going to just put these values in now. So sum of fx squared is 15889.5 over 1500 minus the square of the mean 4841 over 1500 to be squared. Now you may have noticed I didn't just put in 3.23 and square that. The reason is this has been rounded. This is a rounded answer. I don't want to use that rounded answer when I'm calculating the standard deviation, so I'm going to use an exact value, which is this, and then I'll round afterwards. So you're best off using this value rather than this. Right, so let's take our calculator out. So I'm going to do 1588.9.5 over 1500 minus 4841 over 1500. Closing the brackets, squaring that value, and that gives me 0.1773, etc. And then if we take the square root of my answer, square root of my answer, we get 0.421. So 0.421 to three significant figures. 0.421. So the variance is calculated by doing this, and then I take the square root of my answer to get the standard deviation sigma, 0.421. Okay, it says use interpolation to estimate the median birth weight. Now, whenever I'm going to use interpolation, it's always nice to have my cumulative frequencies. So 1, 7, 67, 347, 347, 1167, 1487, 1497, and then 1500. Okay, the cumulative frequencies are handy to have. Now, the median birth weight. The median is going to be found by doing 1500 over 2, which is 750. So I need the 750th value. Now at this point I've got 347. Here I've got 1167. So what do I add on to 347 to bring it up to 750? So if I do 750 minus 347, that tells me 403. So if I add on 403 to this, that will bring me up to 750. So I need 403 out of, well, how many people are in this group altogether? There is 820 frequencies, so I need 403 out of the 820. So that's the proportion I need of this class interval. So I'm going to multiply it by its class width, which we can clearly see is 0.5. And then we always add on the lowest bound. The lower bound in this case is 3. So taking out our calculator, we're going to do 403 over 820 multiply by 0.5 and then add on the lowest bound, gives us 3.25 to three significant figures. So 3.25 to three significant figures. So that's the median. Describe the skewness, giving a reason for your answer. Right, so what I'm going to do is I'm going to compare the mean with the median. The median we've worked out to be 3.25, and the mean we have previously worked out to be 3.23. That means the mean is less than the median, which implies it's negatively skewed. Negatively skewed. You could use quartiles. You could use the Q2 minus Q1 and Q3 minus Q2 comparison. That should give you a negative skew as well, although it's a lot longer to do because you have to work out Q1 and Q3. And you could use 3 times the median, or 3 times the mean minus the median over the standard deviation. That will also give you a negative skew. So any one of those methods, this is the quickest option in this case. Okay, and next question from June 2010. A teacher selects a random sample of 56 students, records to the nearest hour the time spent watching television in a particular week. Find the midpoints of these two groups. Okay, and like I said before, the easiest way to find the midpoint is to add the lowest bound of the upper bound, which will give me 46. 46 divided by 2 gives me 23. 31 and 40 gives me 71, and 71 divided by 2 gives me 35.5. So that's my midpoints done for 2 marks. A histogram was drawn to represent these data. The 11 to 20 group was represented by a bar width of 4 centimeters and height 6. Find the width and height of the 26 to 30 group. These questions tend to be quite challenging for students, but let's work our way through this one and see how we get on. Okay, so I'm going to take the information that I'm given already. So for the class width of 11 to 20 group. So let's have a look at this, the class of 11 to 20. So the class that goes from 11 to 20. What do we know about it? We know that the that actual class, the class width for that group equals, well, the lowest bound is 10.5, the highest bound is 20.5, so the class width is 10. The bar width, so the width of the bar, we're given to be 4, and the height of the bar equals 6. So the class width is 10 and the bar width is 4. Right, now I'm going to use this information to work out the constant k, because the area of a bar is proportional to its frequency. Okay, so the area of a particular bar, the area of a bar is proportional to its frequency. That means that the area of a particular bar will equal some constant multiplied by its frequency. Sometimes the constant is 1, more often than not it's not 1. The area in this case is going to be the width of the bar multiplied by the height, so 4 times 6 is 24, will equal k multiplied by its frequency. Well, the frequency for that group is 15. It's 15. Dividing both sides by 15 to get k. So 24 divided by 15 gives us 1.6. So k is 1.6. Now that's important. I know that k is 1.6. So let's go and have a look at the group that we're asked about. Find the width and height of the 26 to 30 group. So for the class of 26 to 30, what do I know? I know that the class width for this group, the lowest bound is 25.5, the highest bound is 35.5, the class width is 5. That means the width of the bar, because they're all in proportion, if that had a class width of 10, yet the bar was 4 wide, this has a class width of 5, that means the bar must be 2 centimeters wide, because they must be in proportion. And the height is going to be calculated now using k. So I'm looking for the height. Okay, I know that the area of that bar, the area of this particular bar is the width times the height. Let's call the height h. So 2, the width, which is 2, times by the height, must equal the constant multiplied by the frequency. And the frequency for the 26 to 30 group is 13. So that means 2h equals 13k. But k we know is 1.6. So 2h will equal 13 times 1.6. Let's just take the calculator out to avoid any mistakes. So 13 times 1.6 gives me 20.8. So 2h equals 20.8. That means h must equal 10.4. So the height for that group is 10.4. Okay, we're asked to estimate the mean and standard deviation of the time spent watching television by the students. Now this is a great opportunity for me to show you how to use a calculator to do this. So the first thing I'm going to do is hit shift and then set up. Okay, so I'm going to set up, and if I go down, I want to set up the statistics mode. So hit 4, and I want to turn my frequencies on because this question involves frequencies. So turn on the frequencies. Now shift mode, sorry, let's go mode stat. I'll go to statistics mode now. Single variable statistics, so the first option. And what I'm going to put in here, the x is going to be our midpoints, and then I can put in the corresponding frequencies. So 5.5, 15.5, 23, 28, 35.5, and 50. And now I'm going to go up and just alter these frequencies. So the first frequency is 6, next is 15, then we have 11, 13, 8, and 3. Okay, once they're all entered, just hit AC, that will take us back. And if I hit Shift Stat, which is above the 1, and I'm interested in some 4, so if I var, so if I hit 4, I can work out x bar, which is the mean. So I'm going to hit 2 equals 23.5. So to 3 significant figures, we can see that the mean is 23.5. 23.5. And the next thing we're going to work out is the standard deviation. So again, let the calculator do all the hard work here. Shift stat 4 for variability. Now we've got two options. You've got sigma x or sx. Sx you don't want. That's for a population. So you're gonna use number 3, option 3 here. Sigma x, which is 10.71. So 10.71 is the, or 10.7 in this case will do for 3 significant figures. That'll get you your 5 marks nice and easy. Just be very, very careful when you're entering the values into your calculator. But let the calculator do all the hard work. Okay, the next part, use linear interpolation to estimate the median length of time spent watching television by students. In order to do this, I need to work out the cumulative frequencies, which I'll write here. Cumulative frequencies, so we start with 6. 6 and 15 is 21, 32, 45, 53, 56. So that's our cumulative frequencies done. The middle person in a group of 56, or the middle value in a group of 56, so 56 over 2 will give me 28. So we need the 28th value. Here I've got 6, then 21, so I'm going to need another 7 people. I'm going to need another 7 values to take me up to 28. So I need 7 out of the 11 in this group. I need 7 out of 11. That is the proportion I'm interested in. Multiplied by the class width. The class width goes from 20.5 to 25.5, which is a class width of 5. And then add on your lowest bound, which is 20.5. So let's take our calculator out. We need 7 over 11. Let's turn this back into regular mode. 7 out of 11 multiplied by 5 plus 20.5 gives us 23.68. 23.7 to 3 significant figures. So 23.7 to 3 significant figures. Okay, now it says in the next part, a teacher estimated the lower quartile and upper quartile of the time spent watching television to be 15.8 and 29.3 respectively. State, giving a reason, the skewness of the data. The fact it's given you the upper quartile and the lower quartile is a big hint on what you should do. I'm going to compare the quartiles, so I'm going to do Q2 minus Q1, which equals 23.7. Remembering this, our median value is Q2. 23.7 minus Q1, the lower quartile, which is 15.8. So 23.7 minus 15.8 gives us 7.9. And then we're going to do Q3 minus Q2, which is going to be 29.3 minus 23.7. Let's see, adding 5 on 5.6. 5.6. So we can see that 7.9, or Q2 minus Q1, is greater than 5.6. 5.6. So if that's greater than 5.6, so if Q2 minus Q1 is greater than Q3 minus Q2, that implies that it's a negative skew. So a negative skew. Okay, moving on to the next question. Variable x was measured to the nearest whole number. 40 observations are given in the table below. A histogram was drawn with a bar representing the 10 to 15 class had a width of 2 and a height of 5. For the 16 to 18 class, find the width and height. So very similar to the question we did earlier on. So let's write down the okay, so we're dealing with the class of 10 to 15. And just having a look at the data, we can see there's gaps in the data, which means the lowest is 9.5, the highest would be 15.5. That means that the class width for this particular group is 6. The width of the bar, is 2, and the height of the bar equals 5. And like before, we're going to work out the constant k for this particular histogram, because we know that the area is proportional to its frequency. So the area of a bar is proportional to its frequency. That means the area of a bar equals some constant multiplied by the frequency, which means that the area in this case is going to be 2 times 5, which would be 10. So the area of that particular bar is 10, must equal the constant k multiplied by the frequency for that group, which is 15. So dividing both sides by 15, we can see that the constant k equals 2 over 3. So dividing this side and this side by 15, the constant k is 2/3. Okay, so that's important. Now going back to the bar that we're trying to find out information for. So for the class that involves 16 to 18, so that class of 16 to 18 has a class width that's 3. Now I need the width of this particular bar. The width of the bar, well, if the class width of 6 gave me a bar width of 2, a class width of 3 will give me a bar width of 1, because they must be in proportion. The height is what we're trying to find out. And referring back to our table here, we know that the area is proportional to the frequency. So that means the area, which is going to be the width times by the height, must equal some constant k, which we've already worked out, multiplied by the frequency for that particular group. The width we know is 1. The height is what we're looking for, h. That must equal the constant, which is 2/3, multiplied by the frequency, which is 9. So I know that h equals 9 times 2 over 3, which is going to give me 6. So the height is 6. Okay, another question from June 09. A researcher measured the foot lengths of a random sample of 120 10-year-olds. The lengths are summarized below. Use interpolation to estimate the median. So, to estimate the median, as always, I like to work out the cumulative frequency. So that's 5. 5 and 53 is 58. 58 and 29 will give me 87. 87 and 15 gives me 102. Add 11 gives me 113. And add the 7 is 120. So I'm happy that I've added these up, right, because the last digit adds up to the total frequency. Okay, so we're trying to estimate the median. So if there's 120 people in the group, that means the median, or Q2, is going to be the 60th value. So where does that 60th value occur? Well, at this stage here I've got 58, then I've got 87, so I'm going to need another 2 people out of this group. So I need 2 people out of the 29 that's involved for this group here. So I need 2 out of 29 multiplied by the class width. You can see there's no gaps. That means the class width is just 2 in this case, yeah, from 17 to 19. And the lowest bound is 17. So you do 2 out of 29 multiplied by the class width and then add on the lowest bound. So taking out our calculator to do all the work here, 2 over 29 multiplied by 2 and then add on the lowest bound, which gives us 17.1. 17.1 will do. Calculate estimates for the mean and standard deviation. Well, to get the mean and standard deviation, I'm going to let my calculator do all the hard work. I'm going to first write down the values of the midpoints x. So in this case it's 11, 12 and 17 is 29. 29 divided by 2 is 14.5. 17 and 19 29, 36 divided by 2, which is 18. This is going to be 20. This is going to be 22. And then finally 24. So there's all our midpoints. So take out the calculator. Let's return to stat mode. Single variable stats. So I'm going to enter the midpoints, x, and then the frequency, which is the number of children. So we've got 11, then 14.5, 18, 20, 22, and 24. And then entering the frequencies 5, 53, 29, 15, 11, and 7. Okay, once you have your data entered, just hit AC, it'll take you back to the home screen. Shift and then 1, press number 4. And then we want the mean, which is going to be X bar. So the mean is 17.1 to 3 significant figures. So X bar equals 17.1 to 3 significant figures. And we also need the standard deviation. So shift 1 stats, press number 4, and then number 3 for the standard deviation, which is 3.28. 3.28, and obviously we have saved a whole host of time for our 6 marks here. Okay, next part of the question. One measure of skewness is given by 3 times the mean minus the median over the standard deviation. Evaluate this coefficient and comment on the skewness of the data. So we're going to do 3 times, well, the mean is 17.1 minus the median, which is also 17.1, over the standard deviation, which is 3.28. 3.28. And 3 times 17.1 times 17.1. 17.1 minus 17.1 is 0. And then working all that out, we'll find our answer is 0. So that means it's no skew, which implies symmetrically distributed. So symmetrically distributed. Greg suggests that a normal distribution will be suitable for the model for foot lengths of 10-year-old children. Use the values found in part C. Comment on Greg's suggestion, giving a reason for your answer. So as the data is distributed symmetrically, normal distribution can be used as a suitable model. So because the data is symmetric, normal distribution is useful here. Okay, moving on. The age and years of the residents of 2 hotels are shown back-to-back stem and leaf diagram. Write down the mode for the age of residents for the Balmoral Hotel. So the Balmoral Hotel is over here. So let's have a scan of our leaves, and I can see we've got lots of zeros appearing here, which is certainly the mode. So that means the mode for the age for residents in this hotel is 50. Uh, Find the values for the lower quartile, median, and upper quartile for the Balmoral Hotel. Um, so first thing I'm going to do is work out how many people are in this hotel by adding up these values here to get the total number of leaves. So 1, 2, 3, 4, 10, 19, 25, 28, 28 in total. That means the lower quartile, Q1, doing 28 over 4, which is 7. So the seventh person, counting along 1, 2, 3, 4, 5, 6, 7. So Q1 equals 45. Q2 will be the 14th. So counting along 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's Q2. And then finally Q3 will be the 21st person. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So Q3 is 63. 63. Find the mean age of the residents. So, and again, remember this is all for the Balmoral Hotel. So let's put our calculator back in stat mode again. This time you'll notice there are no frequencies. So I'll just show you two ways of doing it. We can leave it in frequency mode like so, as long as we just leave all the frequencies as 1. Or you can hit Shift, Setup, turn off your frequencies, turn off the frequencies, and now if I go mode, stat, single variable, it just asks me for each value. So let's put these values in now. We've got 26, 34, 34, 37, 40, 40, 45, 45, 46, 49, 50 appears 1, 2, 3, 4 times. 51, 53, 56, 56, 57, 62, 63, 63, 64, 65, 67, 70, 71, and then 75. And you'll also notice here that on my calculator it says there 28, which means there's 28 values put in. We had 28 in total, so I'm fairly confident that this will be correct. Okay, hit AC, and now if I hit Shift, Stat, 4, and then 2 for our X bar. So 52.5 will do to 3 significant figures. 52.5 X bar equals 52.5. Given that sum of x squared equals this, find the standard deviation. Now I've already done all the hard work by entering the values. Save me a lot of time. So I can just work out the standard deviation straight away. Shift, stat, var, and then standard deviation is option number 3, which gives me 12.2. So 12.2 to 3 significant figures. 12.2. Okay, moving on to the next part. One measure of skewness is found by doing the mean minus the mode over the standard deviation. Evaluate this measure for the Balmoral Hotel. Well, the mean is 52.5, so we need to do 52.5 minus the mode, which is 50 if I remember correctly. Yes, the mode is 50. Divided by the standard deviation, which we worked out to be 12.2. So, taking it the calculator, 52.5 take away 50 is simply 2.5. 2.5 divided by 12.2 is 0.205 to three significant figures, 0.205. So that's the measure of skewness, which is a slight positive skew. Slight positive skew. It says for the Abbey Hotel, the mode is 39, the mean is 33.2, and the standard deviation measure of skewness is this. Compare the two age distributions for the residents of each hotel. Okay, we have the mean. Let's take a look at the means, because it's always good to comment on a measure of centrality. So I'll type it out. It'll be a little bit easier for you to read. So the Balmoral Hotel has a mean age of 52.5, whereas the Abbey Hotel has a mean age of 33.2. This means that on average, older people stay at the Balmoral Hotel. So that's a comment on a measure of centrality. I'm also going to comment now on the variance of the data, or in this case the standard deviation. The standard deviation of the Balmoral Hotel is 12.2, whereas the Abbey Hotel is 12.7, which means the Abbey Hotel data is slightly more varied. The the Balmoral Hotel has a slightly positive skew to its distribution, whereas the Abbey Hotel has a negative skew. And there should be enough there to get you all 3 marks. Okay, and next question. Summarised below are the distances to the nearest mile travelled to work by random sample of 120 commuters. for this distribution, describe its shape. Just to give you an idea what's going on here. The distribution seems to go up fairly quickly. The number of commuters rises sharply, and then it seems to tail off towards the end. So this would be positively skewed. Positive skew. Don't mix up positive skew with positive correlation. They're completely different. Positive skew. Use linear interpolation to estimate its median. In order to do that, as always, we're going to write down some cumulative frequencies. So cumulative frequencies, 10, 29, let me see, that would be 69, 72, this would be 97, 105, 111, 116, 119, and 120. So the median out of 120 people is going to be the 60th person. So where does that 60th person lie? We've got 29 and then 72, so it falls in between. So I need to add 31 onto 29 to bring me up to 60. So I need 31 out of the 43 in that group, and I'm going to multiply that by the class width, which is, let me see, the gaps in the data, which means it goes from 19.5 to 29.5, so the class width is 10. And then, as always, add on the lowest bound, which is 19.5. So taking out the calculator. So we're going to do 31 out of 43, multiply that by 10, and then add on the class width 19.5, which gives us 26.7. So 26.7 will do to three significant figures. 26.7 miles. The midpoint of each class is represented by x and its corresponding frequency by f, giving sum of fx and sum of fx squared. Estimate the mean and standard deviation for this distribution. So you need to know your formula here. X bar equals the sum of fx over the sum of f. Sum of fx is given to us as 3550, and the sum of the frequencies must be 120. So 3550 out of 120 is 29.6 to three significant figures. 29.6. And to get the standard deviation, I'm going to calculate the variance by doing the mean of the squares. So sum of fx squared over sum of f. So that's the mean of the squares minus the square of the mean. And then take the square root of that. Sum of fx squared is, let's just bring it up here to save a bit of room, 138,020 over 120 minus the square of the mean, 3550 over 120 to be squared. So just plug these into your calculator. 138,020 over 120 minus 3550 over 120 to be squared gives us this 274.99, which means the standard deviation is the square root of that. So take the square root of your answer on the calculator. So I'm going to take the square root of my answer, and that gives me 16.623 significant figures. 16.623 significant figures. Okay, let's move on to the next part of this question. One coefficient of skewness is given by, evaluate this coefficient for this distribution. So, 3 times, well, the mean is 29.6 minus the median, which is 26.7. All over the standard deviation, which is 16.6. So all we're doing now is just plugging these values in. 3 times 29.6 minus 26.7, and then I'm going to divide that by 16.6, which gives us 0.524, to 3 significant figures, 0.524. So a nice handy 3 marks. State whether or not the value of your coefficient is consistent with your description in part A. So yes, it is consistent, as it is greater than 0, therefore also suggests a positive skew. State with reason whether or not you should use the mean or median to represent the data in this distribution. So you should use the median as the data is skewed. And it says state the circumstance under which it would not matter whether you use the mean or the median to represent the data. If the mean equals the median, if the data is symmetrically distributed. So if the mean equals the median or the data is symmetrically distributed, then it doesn't matter whether you use the mean or the median. Right, on we go. Next part. We're given a histogram, and we're told that the diagram shows a histogram of variable t, which represents the time taken in minutes by a group of people to swim 500 meters. Complete the frequency table for t. So, I need to complete the frequency table here, and then estimate the number of people who took longer than 20 minutes to swim. Right, the first thing I'm going to do is check and see if the histogram, if the area of each bar is proportional. So, for example, I know that the area of a histogram is proportional to its frequency. That means the area of any particular bar should equal some constant k multiplied by its frequency. So if I check this bar, if I do the area of this bar, which is going to be 5 times 2, that gives me a value of 10. Now the area is 10. That should equal some constant multiplied by its frequency for that particular group, which I'm told is also 10. that means that k, the constant k, is 1, which is brilliant. If the constant k is 1, to get the frequency, you just multiply the area, you just work out the area of each bar. So this particular bar here, the 18 to 25 group, which we're asked to work out, has a class width of 7 and a height of 5, and then 7 times 5, that's 5. 7 times 5 is 35. So that's 35. And then similarly here, this class width is 15. The height is 1. 15 times 1 is 15. So that's nice and straightforward. Estimate the number of people who took longer than 20 minutes to swim 500 meters. So that took longer than 20 minutes. So that means I'm interested in these two shaded regions here. So let me just shade them in. I want to know what the frequency is for that section and the frequency for this section, and then add them together. Well, the width of this bar is 5, the height is 5. 5 times 5 is 25, so that's 25. And then we also know that this region here is 15, so we do 25 plus 15 gives us 40. Lovely. Find an estimate for the mean time taken, and then it asks for an estimate of the standard deviation. Now there's 7 marks going here. We're going to save ourselves a heap of time by writing down x, our midpoints. So the midpoints, just checking there's no gaps in the data, so I'm just going to add these two together and then divide by 2. So the midpoint is 7.5, then 12, then 16, 18 and 25, 35, I get 43. 43 divided by 2 is 21.5, so 21.5, and then that's 65 divided by 2, which is going to be 32.5, so that's our midpoints. Take out the calculator and let's get this data entered. So I need to turn my frequencies back on, so shift and setup, scroll down to stat. I want to turn my frequencies on here. So mode, stats, single variable. Okay, let's enter our midpoints x. So we got 7.5, then we've got 12, then we've got 16, 21.5, 32.5. Okay, and now just alter the frequencies. So we've got 10, 16, 24, 35, and 15. Okay, now that our data is entered, if I hit shift, stat, var, and I want the mean time taken, so hit number 2 equals 18.91. 18.91. And that saved us an awful lot of time. And the standard deviation, sigma, again shift, stat, var, and then option 3, which is sigma x, gives me 7.26, so 7.26. Find the median and quartiles for t. So the median, and before I find the median, I'm going to first work out a cumulative frequency. Cumulative frequency, let's do this in green. So the cumulative frequencies, we've got 10, 26, 50, 85, and then 100. 100. So the median, Q2, if there's 100 people, Q2 is going to be the middle person, or the 50th person. You see the 50th person is right at the end of this group, so it's 18. You could do it using interpolation, but it's very quickly done this way. So Q2 is 18. Let's do Q1, which will be done in a similar way. It's the 25th person if we've got 100 people. So the 25th person, I have 10 here, then I've got 26, so I need a total, I need 15 out of this group, 15 out of the 16 that's in that group, 15 out of 16. So 15 out of 16 multiplied by the class width. The class width for this group is 4. So the class width is 4. And then we're going to add on the lowest bound, which is 10. So 15 out of 16 multiplied by 4 plus 10. Don't need that. So let's do that on the calculator. 15 over 16, multiply that by 4, and then add on 10. So we get 13.75. The upper quartile is going to be the 75th person. At this point I've got 50, this point I've got 85, so I need a total, I need 25 more people, 25 more of the 35 that's in this group. So 25 out of 35 multiplied by the class width. The class width for this group is 7, and add on the lowest bound, which is 18. So 25 out of 35, multiply that by 7, and then add on 18, and we get 23. So 23 there. One measure of skewness is found by using 3 times the mean minus the median over the standard deviation. Evaluate this measure and describe its skewness. So 3 times the mean is 18.91. The median is 18. The standard deviation is 7.26. So that will be 3 multiplied by 0.91, and then divide that by 7.26. 0.376. 376. Describe the skewness. That implies a positive skew. So a teacher recorded to the nearest hour the time spent watching television during a particular week by each child in a random sample. The times were summarized in a grouped frequency table and represented by a histogram. One of the classes in the grouped frequency distribution was 20 to 29, and its associated frequency was 9. On the histogram, the height of the rectangle representing that class was 3.6 centimeters and the width was 2 centimeters. Part A. Give a reason to support the use of a histogram to represent this data. Well, it's continuous data. So histograms are quite good for representing continuous data. Write down the underlying feature associated with each of the bars in a histogram, and the area is proportional. Proportional to the frequency. The area is proportional to the frequency. Show that on this histogram each child was represented by 0.8 centimeters squared. So in other words, what we're trying to find is K, the constant of proportionality. Right, so we're told that the class, which was 20 to 29, we know has a let me see, a frequency. The frequency equals 9. The height of the bar equals 3.6, and the width equals 2. Now the area of that bar is proportional to its frequency. That means that the area, which comes from the width times the height, so 2 by 3.6 will equal some constant multiplied by the frequency. The frequency we know to be 9, so let's just substitute that in there. 9. So 2 by 3.6 is 7.2, so 7.2 equals 9k, and that implies that k will equal 7.2 divided by 9, which equals 0.8. The total area under the histogram was 24 centimeters squared. Find the total number of children in the group. And as always, the total area is proportional to the total frequency. That means the total area, which is 24, must equal k times by the frequency, which means 24 must equal 0.8 times f. So f will equal 24 divided by 0.8. So 24 divided by 0.8 gives me 30. So the total number of children in the group is 30. Okay, next question. The box plot shown shows a summary of the weights of the luggage in kilograms for each musician in an orchestra on an overseas tour. The airline's recommended weight limit for each musician's luggage was 45 kilograms. Given that none of the musicians' luggage weighed exactly 45 kilograms, state the proportion of musicians whose luggage was below the recommended weight limit. Well, I'm going to draw in the recommended weight limit, which would be here at 45. And from the histogram you can see the lowest value is here. We can clearly see that the middle part of the box plot, or the Q2, is right here, which means 50% must have had luggage below the recommended weight limit. So 50%, or half if you like. Half of the musicians were below the recommended weight limit. A quarter of the musicians had to pay a charge for taking heavy luggage. State the smallest weight for which this charge was made. Well, this is Q3. So this is the upper 25% of the musicians. So if a quarter of them had to pay, that means that the lowest weight for which the charge was made comes from here, which is the third quartile, which is 54 kilograms. 54 kilograms. Explain what you understand by the plus on the box plot in the diagram and suggest an instrument that the owner of this luggage might play. So that the cross, or the plus, is an outlier. And that means it was a particularly heavy instrument. Just off the top of my head, an instrument that I know to be very heavy is a tuba. So it could be a tuba. Or another example that you might have is a piano. Pianos are quite heavy, so it could be a piano. Describe the skewness of the distribution, giving a reason for your answer. So let's do, well, we could do Q2 minus Q1 and Q3 minus Q2, but we can see from the diagram that it's symmetric. Symmetric, as Q2 minus Q1 equals Q3 minus Q2, and we can see that the distance between the median and the first quartile is the same as the distance between the upper quartile and the median. So that means it's symmetric. Next question. A travel agent sells holidays from his shop. The price in pounds of 15 holidays sold on a particular day is shown. Find the mean and standard deviation. So another opportunity to use our calculator. So I'm going to, because it's just values without any frequencies, I'm going to turn off the frequencies. So frequencies are off. Stat mode, single variable, and let's put in our values. So we got 299, 350, 99, 1050, 169, 2100, 2315, 1015, 689, 999, 650, 550, 485, 830, and 475. And we can see there the last value was 15. There was 15 in total. So that's all our data entered. So shift 1, option 4. So the mean, which is x bar, is going to be 805. And the standard deviation sigma, again we'll use the calculator to work that out. Shift 1, option 4, and hit option 3, which is 621 to 3 significant figures. 621 to 3 significant figures. The median and the interquartile range. Now in order to get the median I need to, and the interquartile range, the first thing I'm going to do is put the data in order. So the lowest value is 99. Next we have 169. Any more in the 100? No. 200s. 299. Any more 200s? No. 300s. 350. Any more 300s? No. 400s. 485 and 475. So 475 first. 475. Then 485. Any in the 500s? So we got 550. Any more 500s? No. 600s. So we got 650, 689. Marking them off. 700s, there's none. 800s, 830. Then we get 999. 1015. 1050. 2100. And then finally 2315. Okay, let's just check this 15 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Excellent. The median Q2, if I've got 15 data points, that means Q2 is the 8th value. So counting along, 1, 2, 3, 4, 5, 6, 7, 8. So that's our 8th value, 650. Q1 is going to be calculated. Q1 we find by doing 15 over 4, which goes in 3.75, which means we're going to choose the fourth, because we always round up, fourth value. So 1, 2, 3, 4, Q1 equals 350. And we need Q3, which is 3 times 15 over 4, which is 45 over 4, which is 11.25, which means we're going to choose the 12th value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1015. Okay, so we need the interquartile range, and that's the upper quartile. Take away the lower quartile. 1015 minus 350 665. 665. Okay, an outlier is an observation that falls either more than 1.5 times the IQR above the upper quartile or more than 1.5 times the IQR below the lower quartile. Determine if any prices are outliers. So we got to do a quick test here. So we need 1.5 times by the interquartile, which is 665, above the upper quartile. So I'm going to add on Q3. So that's 1.5 times by 665 plus the upper quartile, which is 1015. So 1.5 times 665 plus 1015 gives me 2012.5. 2012.5. And we're also told that if I do 1.5 times by the interquartile range, 665, and I subtract the lower quartile from that, and I subtract the lower quartile, so Q1 minus, which gives me 350 minus 1.5 times by the interquartile range. So plug that into a calculator. 350 minus 0.5 times by 665 gives me minus 647.5. 647.5. So from this information, can I deduce if there's any outliers? Well, anything above 2012.5 is an outlier. So that's an outlier, and that's an outlier, and there's nothing below this. So 2100 and 2315 are outliers. Okay, next part of the question to come. The travel agent also sells holidays from a website on the internet. The same day he recorded the price of each of 20 holidays sold on the website. The cheapest holiday sold was 98 and the most expensive was 2,400. Quartiles of these data are given and there's no outliers. So we're asked to use the same scale, draw box plots for both holidays. So we need to do a scale. Let's change the color of this so that It's a little bit easier to see. Okay, the cheapest holiday was £98 on that one, and the cheapest holiday was £99. So maybe could we go up in multiples of 50? So let's start here that if this was 50, 100, 150, 200, 253, 354, 455, 556, 657, that's no good. So say hundreds, 100, 200, 3, 4, 5, 6, 7, 8, 9, 1000, 1, 1, 1, 2, 1, 3, 1, 4. So that's not good enough. Maybe 200s, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Okay, that'll have to do. So that's 200, 400, 600, 800, 1000, 1200, 1400, 16, 18 is next. 2000, 2200, 2400, 2600, and so on. Okay, so that's our scale done, and this is the cost of holidays, and it's in pounds. Okay, so let's start with this travel agent from the website. Let's do the website first. Okay, so the quartiles are 305, 1379, 1805. Right, we need 305 as the lower quartile. Well, 300 is going to be right smack bang in the middle, so just marginally bigger than that. And the upper quartile is 1805, which is just going to be a tiny fraction bigger. Okay, so that's the website's lower quartile and upper quartile done. Let's do the median. The median is 1375, 1379. 1300 is going to be right in here. 1350 will be right here. 1379 is roughly around there. We can mark these in a moment. And the lowest value, the cheapest holiday was £98. The cheapest value was £98. Well, that would be £100. So £98 would be just down here. So that was the lowest value. We might have to extend this a little bit. 100. And the highest value was 2400. So 2400 is right here. Okay, and let's just be clear so that the examiner knows that this is the website, and this is the lower quartile, which was 305. The median was 1379. The upper quartile was 1805. Highest value was 2400, and the lowest quartile, or the lowest value, was 98. 98. So that's the website done. Now we need to do um, the shop. So the shop sales. Um, let's see, 650, 350, and 1015. So 350 and 1015 for our quartiles. 300 is right in the middle, so 350 will be right about here. 1015. That will be 1100, 1050, 1015, just marginally bigger. Right there. And the median was 650. So let's mark the median in. 650, 600, that would be 700. 650, right in the middle. So we can write these in as well. This is, we've got 350, 350 here. 1015, and then the Q2 was 650, so 650. We also need to put in the highest and lowest values. The highest value was 2. Oh wait, we've got two outliers as well, 2100 and 2315. So let's mark them in. 2100. That'll be 2100, right bang in the middle. And 2315, 2300, 2315, round about here. So that's 2100, 2315. The highest value that's not an outlier is 1015. 1015. So that's as far as we'll go up to, 1015. 1015. Or sorry, 1050. 1050 is where we need to go to. That will be 1050, round about here. And then lastly, the lowest value, I remember off the top of my head, was 99. Was 99, so just slightly ahead. And there's our two box plots. We've got 1050, and this is 99, and it's also the shop. Right, okay, compare and contrast the sales from the shop and the sales of the website. So I'll just type this in, it'll be a little bit quicker. The shop has a much smaller IQR as depicted by the box plots, which means their sales are less varied. The website has a much higher median than the shop, so on average their sales were higher. So that's two comments there that are based on the information we have for a full 2 marks.